In the last lecture, we have already discussed about the various components of operating system. We had also discussed about various resources available with computer system, how these resources are distributed among computing processes called resource allocation, and how the detail of hardware is hidden from the application programs called resource abstraction has also been discussed. In this lecture, we will study about various types of operating system, for example, batch processing, multi-programming, time sharing, personal computer operating system and real-time operating systems. There are various types of operating systems as discussed following. First, we have batch processing operating systems. It is one of the early types of operating system when computers were large machines and dedicated to execute a single program at a time. The memory layout of a simple batch processing system is shown in this figure. The programmer was given the full access to the entire machine. The users of these systems did not interact directly with the computer systems. As shown in figure, user prepares his job consisting of program and associated data on punched cards and submits it to a computer operator. The computer operator collects the jobs from various users and arranges them in batches. One batch may be consisting of similar types of jobs or mixture of different types of jobs. One complete batch is submitted as a unit to the batch processing operating system for execution. A batch processing operating system reads a series of separate jobs, each with its own data and control information. When the job is completed, its output is printed. With this form of processing, operator or user intervention was reduced as jobs could be serviced one after the other automatically. A memory resident portion of the batch processing operating system, sometimes called the batch monitor, transfer control from one job to another automatically. In this execution, CPU is often idle. This idleness occurs because the speeds of the mechanical input output devices are slower than those of electronic devices such as CPU. To balance the speed mismatch between input output devices and CPU, the concept of spooling, which can be termed as simultaneous peripheral operations online, is introduced. Using spooling, when the CPU is busy to execute some job, the input operations and output operations are performed simultaneously to keep CPU busy in processing the jobs for most of the time as shown in figure. Spooling can keep both the CPU and the input output devices working at much higher rates. Problems of batch processing. First problem is turnaround time is more in batch processing operating system. The turnaround time is the time difference between the time of completion of the job and time of submission of job. Usually in batch processing, turnaround time is very high as it takes a lot of time to create a batch and only after that execution starts. Second problem is CPU remains free for most of the time. CPU remains idle during the time to create batch, time to load the jobs, time to load the input data of jobs and time to print the output of jobs. Third problem is no interaction is possible with the user while jobs are being executed. Due to this, error correction is not possible as they occur. Processing of multiple jobs is also not possible. Advantages of batch processing operating system. First advantage is this is the best operating system for implementing the jobs that require the computer or a peripheral device for an extended period of time, but need very little user interaction. For example, generation of electricity or telephone bills of a city or payroll, etc. Next we have multi-programmed operating system, also known as multi-programming. Batch processing dedicates resources, CPU and memory of a computer system to a single program at a time. Single user cannot keep either the CPU or the input-output devices busy at all the times. Therefore, to increase the utilization of resources, multi-programmed operating system is used. Multi-programming keeps several jobs in memory at one time and are executed concurrently. In multi-programming systems, when one job during execution needs input-output transfer, the CPU switches to the other job and start executing it. When that job needs input-output, the CPU is switched to another job and so on. Eventually, the first job to execute. The CPU will never be idle. Memory layout of multi-programmed operating system has been shown in this figure. In this figure, one can see that there are 5 jobs simultaneously loaded and executing in system. In this figure, initially CPU is working on job 4. Job 1 is performing its input-output operations. Rests of the jobs are in ready state, means waiting for CPU. After some time, CPU switches to job 3 and job 4 starts performing its input-output operations. Again, after some time, CPU switches to job 2 while job 1 has completed its input-output operations and goes in waiting state. This process has also been shown in this figure. Here in this figure, job 1 and job 2 are in ready state. Initially, job 1 gets CPU. After some time, when job 1 requires performing its input-output operations, it goes to waiting state and performs its input-output operations. CPU is allocated to job 2. Again, after completing its input-output operations, job 1 comes back to ready state and waits for CPU. Multi-programming can be defined as interleaved execution of 2 or more than 2 programs. Since there is only one processor, there can be no true simultaneous execution of different programs. Instead, the operating system executes part of one program, then part of another, and so on. To the user, it appears that all programs are executing at the same time. Multi-programming increases CPU utilization by organizing jobs such that CPU always has one to execute. Many real-life situations are common with multi-programming concept. A lawyer does not have a single client at one time. He has many clients in the process of being served at the same time. While one case is waiting to go for trial or to have papers typed, the lawyer can work on another case. Similarly, a judge in court may be hearing many cases at same time. A police officer may be investigating many cases simultaneously. Advantages of multi-programming: throughput of the system is increased as CPU always has one job to execute. Throughput can be defined as the number of jobs completed per unit time. Response time, turnaround time and waiting time decreases in case of multiprogramming. There are few disadvantages of multiprogramming also. First is due to simultaneous presence of more than one job in memory, complex memory management algorithms are required to implement multiprogramming. Second is many jobs present in memory which are not doing input-output operations are always waiting for CPU, and whenever CPU gets free, CPU scheduler is required to select the next job for CPU out of these waiting jobs. Third is to take the maximum benefit of multiprogramming, proper job mix, which means input-output bound and CPU bound processes is required. Fourth is memory protection is required in case of multiprogramming. Next we have time sharing operating system. Batch processing and multiprogramming operating system provide non-interactive computing environment. Time sharing systems were developed to provide interactive use of a computer system at a reasonable cost. Time sharing or multitasking is logical extension of multiprogramming. Multiple processes are executed by the CPU switching between them, but the switching occurs so frequently that the users may interact with each process while it is running. Each user is provided with a small share of CPU called time slice. Every process runs for the time slice it is provided. Either process finishes or goes to waiting stage before its time slice expires. Otherwise, process is interrupted and placed at the rear end of the queue of processes waiting for execution. Time shared operating system allows the many users to share the computer simultaneously. Since each action or command in a time shared system tends to be short, only a little CPU time is needed for each user. As the system switches rapidly from one user to other, each user is given the impression that he has his own computer, whereas actually one computer is being shared among many users. A time shared system uses CPU scheduling and multiprogramming to provide each user with a small portion of time shared computer. In this figure, there are 6 jobs in row and CPU currently is executing job 1. CPU will execute jobs one by one only. The maximum time CPU will serve any job is the time slice, which is a fixed amount of time. This process has also been shown in this figure. Here in this figure, job 1 and job 2 are in ready state. Initially, job 1 gets CPU. After some time, when job 1 requires performing its input-output operations, it goes to waiting state and performs input-output operations. CPU is allocated to job 2. Again, after completing its input-output operations, job 1 comes back to ready state and waits for CPU. In the meanwhile, time slice of job 2 expires and it goes back to ready state for its turn to CPU. The process continues in the same way and so on. The time shared systems are more complex than the multi-programming systems. In time shared systems, multiple processes are managed simultaneously and requires an adequate management of main memory so that processes can be swapped in or swapped out within a short time. There are few advantages of time sharing operating systems. First is resources are used more efficiently. Second, CPU remains busy most of the time. Third, response time is very less. And last one is more interaction of users with programs is possible. There are few disadvantages of time sharing operating systems also. First is frequent swapping of CPU between different processes may decrease the effective utilization of CPU. Program status preservation is required more number of times. Second, more memory is required to accommodate more processes to use resources efficiently. Next, we are going to discuss personal computers. As hardware costs have decreased, it has once again become feasible to have a computer system dedicated to a single user. These types of computer systems are usually called personal computers. Personal computers are microcomputers considerably smaller than and less expensive than mainframe systems. The goals of these operating systems were to provide maximum convenience to user, making it user friendliness, instead of increasing CPU and peripheral utilization. Microsoft Windows, MS-DOS and Apple Macintosh operating systems fall in this category. A personal computer is a general purpose computer whose size, capabilities and cost makes it useful for individuals and operated directly by an end user with no intervening computer operator. This contrasted with the batch processing or time sharing models which allowed larger, more expensive microcomputer and mainframe systems to be used by many people, usually at same time. Therefore, operating system of a personal computer is very simple and less sophisticated. Software applications for most personal computers include but are not limited to word processing, spreadsheets, databases, web browsers and email clients, digital media playback, games and special purpose software applications. Modern personal computers often have connections to the internet, allowing access to World Wide Web and a wide range of other resources. Personal computers may be connected to a local area network either by a cable or a wireless connection. A personal computer may be a desktop computer or a laptop, a tablet or a handheld PC. Next, we are going to discuss workstation. A workstation is a special personal computer designed for technical, mathematical or scientific applications. Normally, workstation is used by one person at a time, commonly connected to a local area network and run multi-user operating systems. Workstations are used for tasks such as computer-aided design, drafting and modeling, computational intensive scientific and engineering calculations, image processing, architectural modeling and computer graphics for animation and motion picture visual effects. There is not much difference between personal computers and workstations. Both are desktop computers. Historically, workstations had offered higher performance than personal computers, especially with respect to CPU and graphics, memory capacity and multitasking capability. Workstations are essentially desktop PCs that have been upgraded heavily with powerful hardware and software, especially keyed towards a certain task. For example, film editors use specially customized workstations to take raw digital footage and edit it into a watchable form. Video game developers also use workstation computers to piece together graphics, animation and sound. Next, we are going to discuss real-time operating system. Real-time operating system runs applications with very precise timing and a high degree of reliability. Real-time operating system is a special purpose operating system that has rigid time constraints for any job to be completed. System responses arrived later than the expected times are either irrelevant or meaningless. Therefore, in real-time operating system, the correctness of the computations not only depends upon logical correctness of computation, but also upon the time at which the result is produced. Main objective of the real-time systems is to provide quick event response times and thus meet the scheduling deadlines. User convenience and resource utilization are secondary concern to real-time operating system. The sensor produces the signal that is interrupted by the operating system as an interrupt. On receiving the interrupt, operating system invokes a special process or a set of processes to serve the interrupt. This can be especially important in measurement and automation systems where downtime is costly or a program delay could cause safety hazard. Some of the examples of real-time systems are medical imaging systems, industrial control systems, telephone switching systems, automobile engine fuel injection systems, air traffic control, missile guidance, etc. Real-time operating system can be categorized in two parts. First is hard real-time operating system. Operating systems that can absolutely guarantee a maximum time for these operations are commonly referred to as hard real-time. In hard real-time operating system, all critical tasks have to be completed strictly within the specified amount of time, that is within the given deadline. In a hard real-time operating system, however, not only tasks must be completed within the specified time frame, but they must be completed correctly. In hard real-time operating system, failures to meet deadlines may cause heavy loss. Consider an example of airbags provided in cars. At the time of requirement, if airbags do not open, it may cost the life to some passenger. Other examples of hard real-time operating system are flight control system, online stock trading system, etc. Second is soft real-time operating system. In a soft real-time system, tasks are completed as fast as possible without having to be completed within a specified time frame. Late completion of jobs is undesirable but not fatal. In soft real-time operating system, if deadline is not met, the system does not fail, but the performance deteriorates. Operating systems that can only guarantee a maximum time most of the time are referred to as soft real-time operating system. Here, system performance degrades as more and more jobs miss their deadlines. Finally, conclusions. There are many types of operating systems designed for various types of applications. Various types of operating systems are batch processing, multi-programming, time sharing, personal computer operating system and real-time operating systems. The major difference between these operating systems is the manner in which they cater to user jobs, manner in which system resources are distributed among various processes and type of jobs to be processed.